operations like update, insert and delete. For relations that do not follow the second normal form or that violates the second normal form, a remedy for such relations is decompose and set up a new relation for each partial key with its dependent attributes. Make sure to keep a relation with the original primary key and any attributes that are fully functionally dependent on it. That means if you are given a relation with a primary key, you have to keep that relation also, but decompose that relation, remove those attributes, those partial keys with its dependent attributes from the relation. There are some examples which will demonstrate the second normal form more clearly. First example, let's consider the relation imp project storing the information about employees and the projects on which those employees work. The function dependencies which are specified here are employee ID and project number determines hours, employee ID determines employee name, project number determines project name and project location. Here employee ID and project number is not is determining the value of employee name, but it is not a full function dependency because alone employee ID can determine the value of employee name. That means employee name can be deduced or we can get the employee name from its employee ID alone. Therefore this function dependency is not a full function dependency, and e name is a non-prime attribute. That means here the violation of second normal form is present. Similarly, the second dependency which we have discussed earlier is also a partial function dependency. Now e name, p name and p location, these are non-prime attributes and they are not fully functionally dependent on the primary key which is imp id and p number. Therefore this relation is not in the second normal form. To normalize this relation to second normal form, we must decompose it into number of second normal form relations in which non-prime attributes are associated only with the part of the primary key on which they are fully functionally dependent. So this was the original relation. After second normalization, we have decomposed the relation into three relations. First relation contains employee ID, project number and hours. Second function dependency holds in the second relation which contains only employee ID and employee name. Third relation contains project number as the primary key and project name and project locations. So now we can see that in first relation EP1, hours is the non-prime attribute and it is fully functionally dependent on the primary key. In the second relation, e name is the non-prime attribute and it is fully functionally dependent on the primary key. In the third relation, p name and p location are non-prime attributes and they are fully functionally dependent on the project number. Hence these three relations are in second normal form. Another example of second normalization is employees skills. Here employee and skill together represent the primary key for the relation, and the function dependency employee determining the value of current work location holds, which is not a full function dependency. Now from the table, from the records, from the tuples, we can see that the value of name of the employee attribute is determining the value of current work location, but current work location is a non-prime attribute and the determinant set is not the primary key. Therefore this function dependency is partial and hence this relation is not in second normal form. For normalizing this relation to second normal form, we have to decompose this relation into two, that is employees, which will contain the name of the employee and the current work location, and second is employees skills, which will contain employee and skill as the primary key. Now these two relations are in second normal form. Neither of these table can suffer from update anomalies because there is no partial dependency in these two relations. But not all second normalized tables are free from update anomalies. Here we can see an example of a table which is in semi-normal form but still suffers from update anomalies. Consider this relation tournament winners that has tournament and year as its primary key, and winner and date of birth of the winner as the non-prime attributes. Here winner or winner date of birth combinations are shown redundantly on multiple records. We can see here that this relation is in second normal form because winner is non-prime attribute and it is fully functionally dependent on the tournament and year. Winner's date of birth is also a non-prime attribute and it is also dependent, fully functionally dependent on the tournament and year. But still this function, this table contains redundancy of data, like in the first record and in the last record the winner is repeated. In the second and in the second last record winner is repeated. Both the attributes winner and winner's date of birth are repeated in multiple records in this table. So this relation will result in an update anomaly. Now what is update anomaly? If we will change the value or we will update or modify the value of a winner or winner name or his date of birth in one of the records, and we do not change the value of that record or that winner or date of birth of the winner in the other redundant records, then the database will become inconsistent. That means if we want to make changes in the database, we have to make changes in all those locations where that record occurs, otherwise the database will become inconsistent. The underlying problem is in this relation was the transitive dependency, to which the winner's date of birth attribute is subject. Now winner's date of birth is actually depends on the winner's name, which in turn depends on the primary key, that is the combination of tournament and year. Now this such type of anomalies, that means such type of tables which are in second normal form but still have update anomalies, still suffer from update anomalies, for such relations we have to address such relations we have third normal form. So this problem of second normalized form, tables suffering from update anomalies, this problem is addressed by the third normal form. It is based on the concept of transitive dependency. Transitive dependency is a function dependency if there is a set of attributes Z that is neither a candidate key nor a subset of any key of R, and both the function dependencies X determines Z and Z determines Y hold, then the function dependency X determines Y is called transitive dependency. That means X determines Y is a transitive dependency through the attributes, set of attributes Z. Now this will be more clear from this example. Consider this relation imp department that stores information about the employees and the departments in which for which those employees work. Here two function dependencies are specified in this relation. First function dependency says that employee ID is functionally determining the value of employee's name, date of birth, address and department number. Second function dependency is that department number functionally determines the value of department name and department's manager ID. Now the dependencies of employee ID determining the value of manager ID and employee ID determining the value of department name. These two dependencies are transitive dependencies through the department number. Now these two when we apply the transitive rule, Armstrong's transitive inference rule on the function dependency 1 and function dependency 2, we can infer that the dependencies imp ID determining manager ID and imp ID determining department name, they are holding in the relation. Therefore these two transitive dependencies are being held in the relation imp department. Here we can see that department number, that means through the attribute through which the transitive dependency is being held, that is neither a key itself nor a subset of the key of the employee department. Also, the dependency of the department's manager ID on the department number is undesirable in employee department table, because department number is not a key of the employee department. So the formal definition of third normal form is: a relation schema R is in third normal form if it is in second normal form and no non-prime attribute of the relation is transitively dependent on the primary key of R. Now we can generalize this definition of third normal form. A relation schema R is in third normal form if whenever a non-trivial dependency X determining A holds in R, then either X is a superkey of R or A is a prime attribute of R. That means if any one of these conditions is satisfied for the non-trivial dependencies X tends to A in R, then that relation will be in third normal form. A relation schema R violates the general definition of third normal form if the function dependency X arrow A holds in R and violates both the conditions A and B. That means violating condition B means A is a non-prime attribute, and violating condition A means that X is not a superset of any key of R, or you can say X is not a super key of R. Therefore, a relation that will be violating the general definition of third normal form, that will contain a functional dependency which will violate both the conditions A and B. That means A will not be a prime attribute and X will not be a super key of R. Hence, if X is not a super key of R, that means X could be a non-prime attribute or it could be a proper subset of the key of relation. Now, if X is a non-prime attribute, then we typically have a transitive dependency that violates third normal form. Whereas if X is a proper subset of any key of R, that means X belongs to some candidate key or primary key of R, then we have a partial dependency that will violate the first condition of third normal form, that is, it will violate the second normal form, and hence it will violate the third normal form, because a relation for being a relation to be in third normal form, it must be in second normal form. So here we can now deduce the alternative definition of third normal form, that a relation schema R is in third normal form if every non-prime attribute of R meets both of the following condition. First condition is that every non-prime attribute is fully functionally dependent on every key of R. That means it is in second normal form and it is non-transitively dependent on every key of R. That means there is no transitive dependency. So the main two conditions for a relation to be in third normal form is that every non-prime attribute should be fully functionally dependent on the every key of R. That means they should be they should be in second normal form, and every non-prime attribute is non-transitively dependent on every key of R. That means there should not be any transitive dependency in the relation. Only then, when these two conditions are satisfied, only then the relation will be in third normal form. For the relations that violate the third normal form, the remedy is decompose and set up a new relation that includes the non-key attributes that functionally determine other non-key attributes. So here are some examples which demonstrate the third normal form. Consider again the example of tournament winners. The functional dependencies that hold here are tournament and year. We have discussed this example earlier, that there is a transitive dependency, functional dependency 1 and functional dependency 2. By applying the transitive rule on these two dependencies, we infer a transitive dependency, that is, tournament and year functionally determines the value of winner date of birth. Hence, there is a transitive dependency in this relation, therefore this relation is not in third normal form. Now, for normalizing the tournament winners to third normal form, we have to decompose the relation, original relation, into two. In the first relation, tournament, year and winner. These three attributes are kept. In the second relation, player and the date of birth is kept. So in the second relation, player is the primary key, and in the first relation, tournament and year are the primary key. So these two relations are in second normal form because the non-prime attribute in the first table is winner, and it is fully functionally dependent on the tournament and year, and also there is no transitive dependency. In the second table you can also see that in where players date of birth are stored, here the primary key is player and non-prime attribute is date of birth. Now date of birth is fully functionally dependent on the primary key, that is player's name, and also there is no transitive dependency in the relation. So these two tables are free from transitive dependencies as well as they are in second normal form, and hence we can say that these two relations are in third normal form, and update anomalies cannot occur in these tables. Second example of a table or a relation which is in second normal form but not in third normal form. Here is an example of the table employee department. This relation is in second normal form. Now this is in second normal form because every non-prime attribute like employee name, date of birth, address, department number, department name and department manager ID, they are fully functionally dependent on the primary key employee ID of the relation. Two functional dependencies which are specified here are employee ID is determining the value of employee's name, date of birth, address and department number. Department number determining the value of department name and department manager ID. Now the dependencies which are transitive here are employee ID determines the value of manager ID and employee ID is determining the value of department name, and these two dependencies are transitive through the attribute department number. And we can see that department number is neither a key itself nor a subset of the key of employee department. For normalizing this relation, because it is containing the transitive dependency, for normalizing this relation to third normal form, we will decompose it into two relations. One is employee ed1 and second is ed2. In ed1, in the first relation, we have stored the information about the employee ID, name, date of birth, address and department number. So here we can see that the first table, in the first table, every non-prime attribute is fully functionally dependent on the primary key, so it is in second normal form, and also there is no non-prime attribute which is transitively dependent on the primary key. So the two conditions of third normal form are satisfied, therefore this relation is in third normal form. Now in the second relation ed2, we store information about the department only, that is the department number, department name and department's manager ID. Here the non-prime attributes department name and department manager ID, they are fully functionally dependent on the primary attribute, hence they are in second normal form. Also there is no such non-prime attribute which is transitively dependent on the primary key, therefore the two conditions of third normal form are satisfied, therefore this relation is also in third normal form. So we have normalized the original imp department table to third normal form by decomposing it into two smaller tables, ed1 and ed2. Informally we can define the various normal forms. Like first normal form, informally we can say that all attributes depend on the key. Informally, second normal form says that all attributes depend on the whole key. Third normal form says that all attributes depend on nothing but the key. After third normal form, next is Boyce Codd normal form. It is a stronger form of third normal form. Every relation is in which is in BSN, that is also in third normal form.